Hello everyone, this is my second video. So here I'm gonna discuss AS Pure Mathematics 1 paper. Uh, so October-November 2024, paper 11. Okay, so here uh, it's 1 hour and 50 minutes, and the main thing you should remember is here again, as same as the mechanics paper. Uh, your correct answer should keep in three significant figures, and unless they are like specify the number of significant figures, and the angle values you should keep for one decimal place. Okay. Yeah, right. Okay, that's it. Okay, so let's move to the first question. Okay, here. mm, In the expansion of kx plus 2 over x to the power 4, where k is positive constant. So those are important things. So k is a positive constant, and the term independent of x equals to 150. Okay, so find the value of k and hence determine the coefficient of x square in the expansion. So in that case, you have to remember the expansion, binomial expansion, let's say. So I hope you guys remember, and even you can find it in your equation booklet that they are providing you. But I would say that try to remember it. Uh, so okay, I will write here. Okay, let's say we have a plus b to the power n. So then we start with n 0. So this is NCR. So n c0, and then a to the power n, and then b to the power 0. And afterwards, what you have to do is we increase the power of first term, which is a, and reduce the power of the first term by 1, and increase the power of the second term by 1. Okay, so then next it's n c1. Okay, and so I should write here a to the power n minus 1 times b, and then here n c2. So a to the power n minus 2, b to the power 2 plus, and so on. Finally, you will have here ncn, and then b to the power n. So this is the expansion that you should remember. Okay, so then we can apply that theory here. They say that the expansion, okay, so in this case n equals 4, and okay, so then they are saying that independent of x is equal to 150. So you have to write the expansion and find the term which is independent of x. Okay, so now let's write down the expansion here. So we have kx plus 2 over x to the power 4. So the power is 4, so 4c0, and then kx to the power 4, and then 2 over x to the power 1. So we no need to write it here, and then sorry, power 0, and then for c1, and then here you have to write kx to the power 3 times 2 over x to the power 1 plus then for c2, and here kx to the power 2, and then 2 over x to the power 2. plus I will write here. So 4c3, and then here you have kx to the power 1, and we should increase by 1, the power of 2 over x. So here 3. So this is the last term, which is 4c4. So then we have to write kx to the power 0, which is 1. So we don't need to write. And then here 2 over x to the power 4. Actually, you no need to write all of these terms, because when you write, you can identify which is the term that is independent of x. Okay, so if you take the first term, it is not independent with x, because we will have x to the power 4 here. And then for the second term, you have here x to the power 3 and times here 1 over x. So we have x square here. And then when you go to third term, yes, here we can see that we have x square, and also we have this, when we take the square of 2 over x, again we have divide x square. So we can cancel out. And so we don't have x here. So in this case, you have to consider the term 3, third term. Okay, so therefore I can write the term independent from x is, that is independent x is this one. So we have 4c2 kx square, and then 2 over x square, and they told us that this term is 150. Okay, so now you have to simplify this one. So 4c2, you can use the calculator and find it. So it would be 6, and then here you will have k square x square, and here 4, here divide by x square equals to 150. So you can cancel out x square, and then okay, so from that one you can find k square. K square is 150 divided by 6 times 4, right, which is 24. So we can write 150 divided by 24, and from this one, k equal plus or minus square root 150 divided by 24. So when we bring square to the other side, you have to put plus or minus, and then the answer is here, you can find. So k equal plus or minus 150, and so 5 over 2. Okay, but they said that k is a positive constant. So we can write, since k is greater than 0, so answer for k is positive 5 over 2, or 2.5. Okay, that part is done. And then what they're asking, find the value of k, hence determine the coefficient of x square in the expansion. Okay, then you have to find what is the term with x square. Okay, so in the first term we have x to the power 4. Third term we don't have x. And here, if you take the fifth term, the last one, you have only 1 over x to the power 4. And in the fourth term, you have x and times 1 over x to the power 3, which is 1 over x to the power 2. So then probably it is the second term, right? You can see here you have x to the power 3 times 1 over x we have. So then it is x square. Okay, so we can write considering the term with the x square. Considering the term with x square, that is this one, 4c1, then kx to the power 3 times 2 over x. Okay, so from this one we can write the coefficient of x square. Therefore, coefficient of x square is this one, 4c1 here. Then we have k to the power 3 and okay, times 2. So we found already the k value. So 4c1 is 4 times k was 5 over 2 cube times 2. So in this case it's 4, 5. Okay, so we will have here. Let's check. I was thinking whether I can do it fine, but it's a bit difficult. Okay, 4 times 2 times 5 to the power 3 divide by 2 to the power 3. So 125. Okay, so it's 125. So this is the answer. Right. So I hope you understood that one. Okay, so now let's move to the second question here. Okay, so say that the curve y equal x square minus a over x has a stationary point at minus 3 comma b. Find the value of the constant a and b. Okay, so what is the stationary point? Stationary point is the point where we have a maximum or minimum point of a curve, right? And so in there we know that if you draw a tangent line, then the gradient is 0. So the gradient we receive by taking the differentiation or derivation of the curve, right? So then first you have to find that one. So what I'm going to do here, but before that I'm going to do a simple modification because here we have a over x. So I'm going to take that one to the numerator minus a to the power minus x. Okay, so now you can differentiate with respect to x. So you have x squared, which is 2x, right? And then, okay, then here you have a is a constant. So minus 1 times minus a is plus a to the power x minus 2. Or I can just again modify a bit. So dy over dx is 2x plus a over x square. Okay, and then at the stationary point, so we can write at the stationary point, we know that dy over dx or the gradient is 0, right? So then I can equate 2x plus a over x square equals to 0. And then we can consider the point because here they say that it has a stationary point at minus 3 comma b, right? So considering the stationary point, considering the point which is minus 3b, so we can substitute the variables here. So here we don't have y, so but we have x value, so we can substitute. So minus 3 plus a over minus 3 square equals to 0. So from this one, you can, let's say, cross multiply. So you have minus 6, 2 times minus 3 minus 6, and then 9. So you can multiply all by 9. So minus 6 times 9 minus 54. And then here plus a equal to 0 times 9, 0. So therefore you can find a is 54. Okay. And then now we know the a value, and so how we can find b. Okay, we know the x value, so we know the graph, right? So what we can do, substituting the point minus 3 comma b to y equals, this is our original equation, and it's a of x. So we can substitute those values to this because we know the x coordinate, and so we can try to find what is the y coordinate. Okay, so here y value is b, so b equals x value is minus 3, so here minus 3 square, and then minus a value is 54 over minus 3. Okay, so from this one we can calculate minus 3 square is 9, and then here plus 54 divided by 3 means 18. So the answer is 27. Okay, therefore the value of b is 27. Okay, so that question is also done. Right, now let's move to the third question. Okay, so here they gave us a diagram, shows that a sector of a circle, center is O, where OPOC is, okay, 15 centimeter. The size of the angle BOC. Okay, so this angle is 2 pi over 5, right? And then okay, point A and D on the line, or D on the line, OB and OC respectively, are joined by an arc AD. Okay, D of a cycle with a center of O. And shaded region is bounded by the arc AD and BC, and by the straight lines AB and DC. So it is given that the area of the shaded region is this one. So the area of this shaded region is this pi centimeter square. Okay, so find the perimeter of the shaded region. Give your answer in terms of pi. Okay, so how we can do? Here we know the area of the shaded region, right? So we can try to find it in another way. So I can write here area of BOC sector. That means the whole part. Okay, so I will write BOC sector. and then I can subtract the area of uh, O, AOD. That means this white color part. Okay, so this is this. Oh, sorry. So we can take this part, right? So the area of that one. So we can say area of AOD sector. That one equals to the shaded area. Okay, so now you should remember how to calculate the area of a sector. Area of uh, sector, we can write half r square theta, and remember theta should be in radians. Okay, right. So we have all the values and we can try to find it. So the first one is the bigger one. So the radius is 15 and we know the angle. So we can write half 15 square times theta, which is 2 pi over 5, minus, then the small part, half, the radius is AO, we can write. So square of that one and the angle equals the area they gave us 209 9 over 5 pi. So here we can cancel pi, and also we can cancel 5. Right. So with that one we can simplify here 2, 17, 5, and also you can and even we can cancel 2 also here. These two cancel, these 2 and these 2 cancel. So 15 square 225 minus a square equals to 209. Okay, and so we can write OA, let's say OA equals to 225 minus 209, which is 16. So we have to take the square root. So which is 4 centimeter. So this is the radius of the small part, OA distance or OD distance. Okay, so now you can write the perimeter of the shaded area. So let's write perimeter of the shaded area. In there, okay, how we can write? So perimeter, we should know AB distance plus DC distance, and then this arc. So AD arc and BC arc. So AD arc plus BC arc. So AB distance is okay. So OA is 15 and sorry, OB is 15 and OA we found that it is 4. So then it is 15 minus 4. And it is same for the DC. So 15 minus 4 plus. And then you should know again how to calculate the arc. The arc distance or arc length we calculate by taking r theta, radius times the angle. So if you take the small one, radius is 4 and the angle is 2 pi over 5 plus For the bigger one, it is 15 times 2 pi over 5. Okay, so here 15 minus 4, 11. So we have two of them. So it's 22 plus, here we have 8 pi over 5 and 35. So total is 38. So 38 pi over 5. So they're asking our answer in terms of pi, right? So this is the answer. Okay. So now let's move to the question 4. So show that the curve with the equation of x square minus 3xy minus 4 equal to 0 and the line with the equation of 3x plus y plus k meet meet for all values of the constant k. Okay, so line and curve are meeting. That means they are intersecting, right? So now you should remember how to find the intersection point, right? So in that case, let's take the first equation, x square minus 3xy minus 40 equals to 0. Let's take this is our first equation. And then the line 3x plus y plus k equals to 0. I'm going to modify a bit. So I'm going to subject y. Y equals then minus k minus 3x. So I will take this one as the second equation. Okay. So at the intersection, y coordinates are the same. So we can substitute. So considering the intersection, we can substitute. So substitute to equation 2. So substitute equation 2 into equation 1. So I can write x square minus 3x. Instead of y, I can write minus k minus 3x. And then here minus 40 equals to 0. So now you have to solve this one. Okay, so when I simplify, so we have x square and minus 3x times here minus 3x. Minus, here we have minus 3x times minus 3x plus 9x. So total is 10x square. And then we have here minus plus. So plus 3kx plus 3kx. Okay. And then minus 40 equals to 0. Okay. Now, what we have to do here in this case. Okay, now this is a quadratic equation. So we have to solve the quadratic equation. But we can't have any answers, right? Because we don't know the k value. Okay. And then we can say that in order to have a real solution, because we need a real solution. So I hope you remember when you solve quadratic equations, sometimes we will have complex solutions also, right? Which is when the determinant or delta or b square minus 4ac, when it is negative, we will have complex solutions. Other than that, we will have real solutions. So I can write in order to have real solutions, the determinant determinant or delta, which is b square minus 4ac, should be greater than 0. Okay, so now you have the quadratic equation, so you can write b square minus 4ac. So b is here 3k square minus 4a is 10 and c is minus 40 greater than 0. So you will have here 9k square, here minus plus 4 times 4 16, so 1600 greater than 0. Okay, now how you can solve this one? Here no need to solve, okay, because as you can see 9 is positive, k square we don't care whether the values of k is negative or positive. We are taking the square, so it is positive. Confirm. And then, okay, therefore we can say that 9k square is positive. Then here for a positive number, we added another positive number which is 1600. So it is also positive. So we can say that 9 times k square plus 1600 is always positive regardless the value of k, right? So I can write therefore 9k square plus 1600 is always positive. And okay, what's the meaning of this inequality? So we have this 9k square plus 1600 greater than 0. So the meaning of that one is find the k value which gives you positive answers here greater than 0. So here you have the left side. So they are asking what are the k value which makes this left side is positive. But here nothing to do because it is always positive, right? By logic. Okay, so it's positive. Therefore, we can say that. Therefore, um, the curve and the line intersect for all real values real values of k. Okay, so this is the answer. Right. Now we are moving to the fifth question. Okay, so it's okay, 3 points. So also I would say that focus, like check how many points they are going to give you. Okay, so from that one you can have an idea about like what you should do here. Right. So in this question, uh, the uh, the equation of a curve is such that dy over dx equals this one. Find the coordinate of the point on a curve which the gradient is this. So you should know, like when you see dy over dx, that is the gradient, right? So, okay, let's say we have a curve something like this, right? So we take a point and we draw. Okay, so let's say this is the equation y. So the gradient is given by dy over dx, right? So here they gave us dy over dx, and that is the gradient, the general equation of the gradient, and the gradient value they gave us. Okay, so what we can do here, we can just equate them. So the the gradient dy over dx, which is 4x minus 3 root x plus 1. This is equals to 2. And now you can solve this one. So I can multiply by 2 all the terms. So we have 8x minus 6 root x plus 2 equals 11. And so I want to find answers for x. So how we can solve this one? Okay, here for this kind of question, the problem is the root x. So let's subject root x. Okay, so I can bring 6 root x to the other side, so then it's positive, and 11 we can bring to the other side, so then it's minus. So 2 minus 11 is minus 9. So I can write here 6 root x equals to 8x minus 9, right? Minus 9. Oh, sorry. Minus 9 here. Now you can take the square of both sides. So with that one, we can remove the square root. So when I take the square, so square of 6 is 36 here. And when you take the square of square root, it's this one. And then we have here 8x minus 9 square. So we have to solve this one. So 36x equals, here we have 64x square, and then 2 times 8x minus 9x, so it is minus 180x, and then plus minus 9 square is plus 81. So when I bring 36 to the other side, it is again minus yes, sorry, I think I made a mistake here, not 180, sorry. So it should be 2 times 16 times 9, 144. 44x. And then when I bring 36 to the other side, then 4, 50, 180. Okay, so you have 64x square minus 180x plus 81 equals to 0. Okay, so now you have to solve this one. You can use the formula. Minus b plus or minus b square. Square root b square minus 4ac over 2a. So I can write minus b minus 180 plus or minus b square minus 180 square minus 4a is 64 here. Sorry. Okay, here 64 and c is 81. And divide by 2a. A is 64. Okay, so you can simplify this one, and you will find x equal 9 over 4 or x equal 9 over 16. Right, so now we have a problem because we don't know which answer we should use. So for that one, what you have to do is just substitute to the main equation. So here 4, okay, so we can just try here. So for the first one, when x equal 9 over 4, then dy over dx equals here 4, 9 over 4. It's just a rough work. And here 9 over 4 plus 1. So the answer is here 9. And when you take the root, so it's 2, 3. And so the answer is 11 over 2. Okay. And then you can consider in the same way, you can substitute 9 over 16. So in that case, you will not receive 11 over 2 because here they say that the gradient is 11 over 2. Okay, so when you substitute x equal 9 over 16 to dy over dx, you will not receive 11 over 2. So then uh, we can neglect x equal 9 over 16. Therefore, the answer is x equal 9 over done. Then part B. Given that the curve passing through a point 4, 11, find the equation of the curve. Okay, so in that case, we have to find the equation of the curve. So we know the differentiation, right? dy over dx. So when from that one, if you want to find the equation, then you have to integrate it. So we can write y equals integration of 4x minus 3 root x plus 1. That one was our equation. Okay, with respect to x. Okay, so this is not a definite integral. So we can write here for the integration of x is x squared over 2 minus 3 is a constant, so we can keep it there. And then x root x means x to the power half. So x equal half plus 1, so 3 over 2. And we should divide by 3 over 2 plus the integration of 1 is x. And we have to write the constant plus c. So with that one, we can just simplify. So y equals, we will have 2x square. So 3 cancel and 2 times, yeah, minus 2 times x to the power 3 over 2 plus x plus c. Okay, and the curve, okay, this curve is passing through the point 4, 11. So they gave you this one to find the value for c. Okay, since okay, the curve, let's say this curve is passing through the point 4, 11. So you can substitute it here. So y value is 11, 2 value is x value is 4. So here 4 square minus 2 times 4 to the power 3 over 2 plus here 4 plus c. So here we have 11 and 1632 here. Minus here we have, okay, for 2 to the power 3, 8 times 16. Then here plus 4 plus c. So with this one, you can find c value is okay, 16, 20, and minus 9. Okay, therefore we can write the equation of the curve. Therefore, the equation of the curve is y equals 2x squared minus 2x 3 over 2 plus x minus 9. Okay, so this question is also done. Right. Now question 6. Okay. Circular measures. Let's see. Or coordinate geometry. Okay. Circle C1 and C2 have equations. Okay, these are these are the equations and respectively. Okay, find the distance between center of the circles. Okay, here the main thing you should remember is, so they can give you the equation of a circle in two ways, right? So the first one is in this form, quadratic form, y minus b square equals to r square. So in there, with that one, you can write the center. Center is a comma b, and the radius is r. So this is the first method. And if your equation is in this format, x square plus y square plus 2gx plus 2fy plus c equals 0. Okay, then the center is minus g minus f, and the radius is g square plus f square minus c, and the root of this one. So you have to remember those. Okay, so with that one, we can first find the center and the radius of these two. So let's take the equation 1. So let's take, that is the circle 1. X square plus y square plus 6x minus 10y plus 18 equals to 0. So I would tell you the easiest way to find the center here. What you have to do is just write minus 2g, and then write down the coefficient of x, which is 6. So from this one you can find g. So here g equals minus 3. Okay, and then the next one is minus 2f. Okay, and so from that one you can find minus 2f equals to minus 10. Okay, so from this one you can write f equals okay, here f equals 5. Okay, so so this is these are the points, right? And then okay, with the with the help of this one, you can find the center of that one, and also okay. So from this one, let's write down all. So the center of C1 is minus 3 comma 5. Okay, and then let's find the radius also. The radius, let's say simple r1. So it is g square plus f square minus c. So g square minus 3 square plus 5 square, and c value minus c, which is 18. So when you simplify this one, you will receive 4. So let's keep that one there, because maybe we have to use that one again. And then let's take C2. Okay, C2 equation is this one, x minus 9 square plus y plus 4 square minus 64 equals to 0. And now I'm going to modify a little bit. So x minus 9 square plus here y minus 4 square. Why did I wrote like this? Why did I write that? Because here in general form we have minus a minus b. So in the middle we have minus. So I created that one. And then 64 we can write as 8 square, right? Therefore, we can say center of C2 is 9 comma minus 4. The radius is 8. Okay. Okay, that's it's done. And then we have to find the center to center distance. So that means, okay, I will just indicate here. So you have a one coordinate which is minus 3 comma 5, and then here you have another coordinate which is 9 comma minus 4. Here you have another coordinate which is 9 comma minus 4. So they are asking the distance of this line. So what we have to do, we have to take the square root of difference of x coordinates. So we have 9 minus 3. We take the square and plus the square of the difference of y coordinates. So minus 4 minus 5 square. And so we will have here 12 square plus here 9 square. 25. So it's 15. Okay, so this is the answer here. So now the next one. P and Q are point on C1 and C2 respectively. The distance between P and Q is denoted by D. Find the greatest and the least possible values. Okay, so this is an interesting part. Let me see whether I can draw a circle. Okay, so I will try to draw like this. Okay, so here as you can see, the radius of one circle is 8 and the other one is 4. Okay, so you should remember, if two circles are touching outside, then the center to center distance. Touching outside means something like this. This one, oh, not inside, like this. So then center to center distance is summation of the radiuses, right? But here, the summation of the radius is 12. But the center to center distance is 15. So that means they are not touching outside. So they are separate circles. So I can draw like this. So let's say this is C1. The radius is 4. Okay, so then it's a little bit small, let's say. Okay, a bit small circle. And the other one is a little bit big. So we have the center of C1 and this is center of C2. Okay, so now when we take the distance, so this total distance is 15. The total distance from here to here. Okay, and so here the radius for C1, this distance is 4, this is 8. Okay, this is 8. So this distance is then 3. Okay, so if we consider uh, the point, let's say this is P and Q, P and Q. So this is the let's say the least possible value, which is 3, right? Because other than that, after these points, they are further away. And then also when you increase to this one, so we will have maybe P and Q is here. So the total distances. So I can write the least possible value for D. Least possible value for D equals to 15 minus the summation of radius. So which is 4 plus 8. So it's 3. And then greatest possible value for D is then 15. The center to center distance is 15 plus you have to add another 2 radiuses. So 4 plus, and from the other side it's 8. So which is 27. Okay, so that is the answer for this question. Let's move to question 7. Okay, so we have a graph. Okay, so the diagram shows a part of a curve with the equation of y equal to a lower cubic root of 2x plus 1. The point A on the curve has the coordinates. So the coordinates of A is 7 over 2, comma 6. Okay, so that means this value is, sorry, 6. This y coordinate is 6. Okay, find the equation of the tangent to curve at A, and then give your answer in the form of y equal mx plus c. Okay, so that means they are asking us to draw a tangent line at A. So a tangent line. And the equation of this tangent line we have to indicate as y equal mx plus c. Right. So you know that we have the equation of the curve, and by differentiating, take the derivation, you can find the tangent, right? And then you have the tangent, and the gradient you can find by substituting 7 over 2, because we want to find the gradient of the tangent line at point A. So the first target is to find out the tangent. So we can write the equation of the tangent you can find by taking dy over dx. Okay, so here I would modify this equation a little bit. So here we have y equal, so I will bring all to the numerator. So 12 times here 2x plus 1 to the power minus 1 over 3. So then it's easy for us to differentiate. Okay, so 12 is a constant, so let's keep it, times minus So we have to multiply by the power, yes, and then we have 2x plus 1 minus 1 over 3 minus 1. And then we have to multiply by the differentiation of inside of the bracket. So 2x plus 1. So the derivation of 2x is 2 times, plus 1 is a constant, so it's 0. Okay, so this is the one. And from this, you can simplify a little bit. 12, 24, 24 over 3 is so minus 8. Minus 8, we have here 2x plus 1 to the power minus 4 over 3. Okay, so this is our differentiation. Then we can find the gradient at that point. So therefore, the gradient at 7 over 2, 6. So what you have to do, just substitute the x value. X is 7 over 2. So I'm going to substitute here. So we have minus 8, 2 times 7 over 2 plus 1 minus 4 over 2. So you can use the calculator, or you can just try to do so. 7, 8 times here minus 4. So if you simplify this, you will receive the answer minus half. So minus half. Okay. Then, so they say that the equation of the gradient, we have to take y equal mx plus c. So since we can, right? Since the equation, the tangent is y equal mx plus c, we can write m equal minus half, because why? Here dy over dx also gives us the tangent, and when you substitute the x value, you will receive the gradient of that tangent line. So then we can use that one here. So m is the gradient. So resulting y equals minus half x plus c. So now we have a problem because we don't know the value for c. So we have to find it. It's easy because this tangent line, again, passing through point A. So we can write, since this line, this tangent line is passing through to the point 7 over 2, 6. You can substitute that one. So y coordinate is 6 minus half, x coordinate is 7 over 2 plus c. So with this one, can find c value is 7 over 4, minus 7 over 4 goes to other side, so 6 plus 7 over 4, which is 31 over 4. Okay, therefore the equation is y equals minus half x plus 31 over 4. Okay, and then part B, they are asking to find the area, right? Find the area covered, bounded by the curve and the line of this one. So x equals 0, x equals this one. So that means here x equals 0 means the y-axis, and then x equals 7 over 2. So they are asking you to find the area here, this one, right? So this is the area they are asking you to find out. So we can find it easily. We have to use the integration knowledge, right? So area under curve. A equals y dx. Okay, so area. And so we have to find from x0 to x7 over 2. And the equation, we have this one. This is the equation, but here I have the modified one or the simplified one, right? Which is much easier. Oh, but let's write down the equation first. So 12 over root 3, here 2x plus 1 dx. So I can just modify a little bit. So 7 over 2. So 12. So I can take out, okay, wait. So 12 is a constant. So I can take out 12. So 0, 7 over 2, and I will bring this one, 2x plus 1 minus 1 over 3 dx. So this is a definite integral. Okay, so now we can find a equals 12 and the integration. So we have this one, 2x plus 1 minus 1 over 3 plus 1, right? When we integrate, we have to add 1. And then here also minus 3. So we have to divide by the power. And also remember here, we have 2. We have a coefficient of x. So if you have a coefficient of x, you have to divide it by that one also. Okay, so here I highlighted it to understand why we divided by 2. And here lower limit and the upper limit. Okay, so if I simplify this one a bit, so minus 1 over 3 plus 1 is 2 over 3, so it's 4, and then it becomes 3 over 4. So I can bring to the other side because it's a constant, so you can take it out. So 12 times, yeah, 3 over 4. And then I have here 2x plus 1 to the power 2 over 3, right? And then I can substitute the limit values. So 2 times 7 over 2 to the power 2 over 3 minus, we have to substitute 0. So this one, and this is also 2 over 3. Okay. So A equals, here we have 9, and here we have to do cancel 7. Sorry, here 2 times 7 plus 1. Okay, here we have plus 1 also. Sorry, I missed it. So here you have 2 times 7 over 2 plus 1 or 2 over 3. So 2 cancel, 7, 8, and 8 to the power, cubic root is 2, then 2 square is 4, right? So here 4 minus 1, and so it's 3, therefore A equal 27. Okay, done. So I hope you guys are following this. And if you have any doubt, just leave a comment. And if you want any other papers to discuss, or if you have any suggestion, so please feel free to comment. Okay, right. So this is the eighth question. It is given that beta is an angle between 90 and 180. Okay, such that sine beta equals A, and express tan square beta minus 3 sine beta cos beta in terms of A. Okay, so first here, as you can see, here we have cos beta, right? So we know sine beta, so we have to find cos beta also. So as they are saying here, I'll show you. Okay, so we have the Cartesian plane here, and as they're saying, the beta value is in between 90 and 180. So it is an angle in the second quadrant. Okay, so it's in the second quadrant. So it should be like this. So this angle should be beta. Okay, so then this angle is pi minus beta. So now what I'm going to do is I'm taking sine pi minus beta. So now you should remember how we can write sine pi minus beta. So in the second quadrant, sine values are positive, all St. Thomas College, right? Do you remember? All St. Thomas College. So in the second quadrant, sine values are positive, and we say the angle with respect to pi. So then sine becomes sine. So we can write sine beta, which is A. So in the same way, I can write cos pi minus beta. So in the second quadrant, cos values are negative, so minus, and cos beta. Okay, so minus cos beta. Okay, so now sine beta. Okay, here as we can see, sine pi minus uh, sine pi minus beta is also A. That means if I complete this triangle, okay, then what do we have? So sine pi minus beta is A. So that means the opposite is A and the hypotenuse is 1. So then you can find what is the adjacent. Adjacent is square root of 1 square minus A square using Pythagoras, right? So then I can write here cos beta is minus this one, 1 minus A square over 1. So which is minus 1 minus A square. Okay, so now we know cos beta and sine beta. So here you have to find it first. Okay, so now we have to find the answer for this one, which is tan square beta minus 3 sine beta times cos beta. So tan beta, I can write sine square beta over cos square beta minus, okay, here 3 sine beta cos beta. So we know the values. So sine is A, so sine square, which is A square. And cos square beta, cos beta is minus root 1 over a minus, so square of that one, minus 3 times, sorry, minus 3 times sine beta is a times cos beta is minus 1 minus a square. Okay, with this one you can find here you have a square over minus square is plus, and we cancel the root. So minus a square, and here minus minus plus 3a root 1 minus a square. Okay, so it's 3 point. So maybe it is for the final answer. And to the substitution, like here you use sine, instead of tan, you use sine square beta divided by cos square beta. So for the simplification, and also probably for the answer of cos beta. Okay, so right. And then okay, so in this part they're asking only that one. And then okay, the second part B, solve the equation of sine square plus 2 cos square theta equal 4 sine theta plus 3 for this one. Okay, this is interesting. How we can do? So here we have a problem. So what you can do here is we have cos square also. So it's a problem, right? So we have to have all in one term. So I would tell you one let's say a trick. So here you have sine square, and also you have sine theta. So you have sine square theta and sine theta. So you should give the priority to sine theta. So you have to convert all the other things into sine. So how we can write cos square theta in terms of sine? So you should remember this one. Sine square theta plus cos square theta equals 1. Right? So from this one you can find what is cos square theta, which is 1 minus sine square. So you can substitute that, right? So what I'm going to do here is, okay, so sine square theta plus 2 cos square theta equals, here we have 4 sine theta plus 3. So here sine square theta plus 2 times, instead of cos square theta I can write 1 minus sine square theta, and then I will bring all the other to this side. 4 sine theta minus 3 equals to 0. So here you will receive now sine square theta when I multiply by 2 minus sine square theta, 2 minus 2 sine square theta. So it becomes minus sine square theta, and then here we have 4. I'm rearranging that one also, and then we have minus 3, and from the bracket we have 2. So it is minus 1 equals to 0. So you can multiply by minus. So you can have sine square theta plus 4 sine theta plus 1 equals to 0. So now it is not easy to solve it directly. So you can use the formula. So sine theta, because this is a quadratic equation. So sine theta equals minus b. So minus b is 4 plus or minus b square, which is 4 square minus 4. A is 1, c is 1. Divide by 2a. Okay, so we will receive here sine theta. Theta equals minus o plus o minus. Here you will have 16 minus 12. Over 2. And also I can simplify a little bit. So 12 I can write 4 times 3. So root of 4 is 2, right? So I can write here minus 4 divided by 2 is 2 plus or minus 2 root 3. Okay. And then here we have two answers, which is sine theta equals to minus 4 plus root, sorry, 2 to cancel, then it's root 3. So it is root 3. Sorry, I'm sorry. So here we have minus 2 plus root 3 or sine theta equals minus 2 minus root 3. But here minus 2 minus 3 means you have to add them, right? So when you add them, the answer is more than minus 1, because we know that the sign values are in between minus 1 and plus 1. So we can't take that answer. Therefore, sine theta is minus 2 plus root 3. So from that one, you can find eta, right? From this one, theta equal sine inverse minus 2 plus root 3, which is equals to minus 15.54 degrees. But now, this is not our answer, because, okay, we want to find the answers for theta. But this is not our answer, because here, pay attention on the range that they gave us. So our answer should be in between 0 to 360. What we have to do now? So easiest way is, oops, sorry. You should draw the equation. Okay, you have to draw the graph of sine theta. So I would take like this. Right. So the graph of sine theta. We start with 0. And we have to stop at 360. Right? We here 180. Here 360. This is theta. This is sine theta. And also for the negative side. Sorry. Also for the negative side here. But we don't care about that one. Okay, so now we have here a negative value, which is minus 2 root 3, right? So it is minus 2 root plus root 3 plus root 3. So that is the line. Sorry. Okay. I will take a different color. Okay. So here, if I draw this line, I should move a little bit. Okay. So this is the line. So here, this value is the value that we found here, minus 15.540. Okay, so now according to the symmetry, okay, so the next value you will find here and here, next value, right? Okay, so this value you can find by taking 180 plus by symmetry, this is small piece is 15.54, and this part is also the same, but 360 minus 15.5. Okay, so therefore we can write theta equals to 180 plus 15.54, or theta equal 360 minus 15.54. Therefore, theta equals, so for one decimal place we have to keep because these are angles. Sorry, so I have to put degrees as well here. So then it is 195.5, or theta equals, the difference is 344. So this is the answer. Okay, so I hope you guys understood well. And let me know if you have any doubts. Right. Now, ninth question. Okay, the equation of a curve is given by this one. And then find the set of value of which x. Okay, values of x which y decreases as x increases. So you should remember, when x decreases, okay, sorry, x increases and y decreases. So in that case, we find that one by considering the gradient of the graph, because I will quickly explain it. Let's say we have a graph here and we have a particular point. So in this part, so if I draw a gradient, here the gradient is negative, right? So here dy over dx is negative. And if I consider the other part here, sorry, it's not the gradient. So here dy over dx is positive, right? So here for this side x increases, right? So when x increases, y decreases. So we can find that one by taking the differentiation less than 0. So this is the target, and you should remember that. So first, gradient of the curve we have to find. Gradient of the curve, we can write dy over dx. So 4 is 0, 5 plus 12x minus 9x squared. Okay, and then we have to find the stationary point. Okay, because later we have to use them. Yeah, it will be easy for us if we find the stationary point. So at the stationary points, we know that dy over dx is 0, right? So we can write 5 plus 12x minus 9x squared equals to 0. So I can write here minus 3x minus 3x, sorry, plus 3x, because when you multiply these two, we should receive minus 9. And we have plus 12. So I would write here plus 5 minus 1. No, because plus 5, and yes, this is. Okay, therefore we will have here minus 3x plus 5 equal to 0, or 3x plus 1 equals to 0. So that means x equals 5 over 3, or x equal minus 1 over 3. Right. So we can say that y decreases when dy over dx less than 0. So we found dy over dx, which is this one, 5 plus 12x minus 9x squared, right? Less than 0. Okay. So what I can do here, I will do one trick. So I will multiply by minus. So x squared minus 12x minus 5. So now it's greater than 0. And we know already the answers for this one, right? Which is, here we found this 2 points, 2 answers for this one. So I will tell you the trick. So here one answer is x equal 5 over 3. So bring 5 over 3 to the other side. So then it becomes x minus 5 over 3. So it's a factor, x minus 5 over 3. And also the other one. So x and minus 1 over 3 goes to other side. So then plus 0. And you should remember the easiest way is to find here when you have two brackets and greater than 0, then the answers are x less than the smallest value and greater than the biggest value. So that means x less than the smallest value. Smallest value is minus 1 over 3, right? And x should be greater than the biggest value, which is 5 over 3. Let's say in case if you forget or if you have a doubt with doing that. So what you have to do, draw the line number line, indicate two values. So minus 1 over 3 and here 5 over 3. And then we will check the regions. So here you have the multiplication of two brackets. So substitute a value which is less than 1 or minus 1 over 3. You can put, let's say, minus 5. So we substitute minus 5 to x. So minus 5 minus 5 over 3, a negative number. We just check the sign. And then in the next bracket, minus 5 plus 1 over 3, you will receive minus answer, right? So minus times minus plus. Then between minus 1 over 3, 5 over 3. So these two are negative number and positive number. Easiest value is 0. So if you substitute x equals 0 here, then in the first bracket, it is minus 5 over 3. And then the next one, it's 1 over 3. So minus times plus. So it's then minus. And then a number which is greater than 5 over 3. Let's say 10. So if you put into the first bracket, 10 minus 5 over 3, positive. 10 plus 1 over 3, again positive. So positive times positive, positive. So you need to find the values which are positive because here the multiplication should be greater than 0. It means positive. So you have positive region here, positive region here. So x should be less than minus 1 over 3 or greater than 5 over 3. Okay, so this is the easiest way to do that. Okay, right. Then, okay, part B. Part B. Yeah, okay, it is given that y equal 9x plus k is a tangent to that curve. Okay, find the value of the constant k. Okay. Hmm. Okay, let's consider like this. This is okay. Is given that okay, this line is a tangent. Okay, so then what is the gradient of that tangent? Is 9, right? So we have, oh, sorry, I forgot to change the one. So we have y equal 9x plus k, right? Then, so the gradient line is 9. Okay, let's keep that in mind. And also the gradient of the curve is given by, here previously, we found that the gradient of the curve is given by this derivation, right? This one, dy over dx. So we can write that one. So also the gradient of the curve is given by dy over dx equals, what was it? 5 plus 1. Okay. So it is 5 plus 12x minus 9x square. This is the gradient, and we know that that value is 9. Okay. So then we can simplify this one. So we can bring all to the right side. So 9x square minus 12x minus 5 plus 9 is plus 4 equals to 0. And this is the 3x minus 2 square. Am I correct? Yes, 3x square 9 and then 2 times 3x times minus 2 is minus 12 and minus 2 square is plus 4. And then we can simplify. We can bring square to the other side. So root of 0 is 0. And so x equals 2 over 3 here. Okay. So our target is to find the value of constant k. Okay. Now we can use, okay, we know the x value. We know the x value uh, of the tangent line, which gives the gradient 9, right? Okay, so as an example, how can I do that? Let's see. Okay, this is just an example. Okay, so this curve is a cubic, right? So maybe the curve is something like this, and then we have this line. So let's take this is the line. So this equation is y equals 4 plus 5x plus 6x square minus 3x cube. Am I correct? Yes, 3x cube. Okay, so this is the equation. And so the equation of the gradient over the tangent line is y equals 9x plus k. So this is the point. And so at that point, the x value is 2 over 3, and we don't know y value. Okay, yet. So we can, so here the point is at both, on this both curve and the line, right? So you can substitute this x value to the curve and find the y coordinate. Okay, so using the equation of the curve y equals 4 plus 5x plus 6x square minus 3x cubed. And then substitute x equal 2 over 3. So then you can substitute that one. So y equals 4 plus here 5, 2 over 3 plus 6, 2 over 3 square minus 3 here 2 over 3 cube. So you can use you can use the calculator and simplify this one. Okay, so the answer will be 82 over 9. Right, so we can now write, since the line is passing through this point, so 2 over 3 and 82 over 9, we can substitute that one into this equation, y equal 9. So y coordinate is 82 over 9 equals to 9 times x coordinate is 2 over 3 and plus k. So from this one you can find k equals 82 over 9 minus 6. So it will be 28 over 9. Okay, it's done. So now we are reaching to the final part. Okay, so question 10. An arithmetic progression has 5 terms. Okay, oh sorry, the first term is 5 and the common difference is d, where d is greater than 0. The second, fifth and 11th terms of the arithmetic progression in that order are the first 3 terms of the geometric. Okay, so so first you should remember the equation for the arithmetic progression and the geometric progression. So if I take arithmetic progression, the nth I can write a plus n minus 1d, and for the geometric progression, nth term is a, the first term, times the common ratio n minus 1. Okay, so we have to remember that one. So now let's write the arithmetic progression. The arithmetic so first term is 5, so the second term is we have to add 5, right? So first term is 5 and second one is 5 plus d second, and third term is 5 plus 3 minus 1 is 4. So 5 minus 4d and so on. Okay, let's say fourth term also. If I put here the fourth term, we will have 4 minus 1, 3. Sorry. Here the third term, so then I should have here 5 plus, okay, 2d, and then 5 plus 3d and so on. Okay, and and then therefore the geometric progression. Okay, so geometric. So they say that the first three term of, okay, so the second, fifth, and 11th. So second term is the first one. So it is 5 plus d. Second, fifth. So fifth one, you can put n equal 5. So then it is 4d. So 5 plus 4d. And the 11th. So then 11th term is 5 plus, so 11 minus 1 is 10. So 5 plus 10d. And so on. So now what you can do? So we have to find d value. So we know that we have the common ratio, right? Considering the common ratio. Considering common ratio, we can write second term, which is 5 plus 4d, divide by the first term, 5 plus d, and then the third term, 10d, divide by the second term. So this ratio should be the same. So then we can cross multiply. So we have 5 plus 4d square times 5 plus 10d times 5 plus d. So when you simplify, here we have 25 plus 40d plus 16d square, and here we have, okay, so we have 10d square plus 55d plus 25. So here we can cancel 25. So we will have here 6d square minus 10d equals 0. So d equals 6d minus 15 equals to 0. So we know that d cannot be 0. Therefore, because they told us 6d minus, sorry. So now we can write 6d minus 15 equals to 0. So d equals 15 over 6, which is 5 over 2, or you can write 2.5. Okay, so let's write down the common ratio. Ratio of the geometric progression. So you can take any of this this part. So let's say 5 plus 4, here 2.5, divide by 5 plus d, which is 5 plus 2. So when you simplify, the answer will be 2. So we will have to use that. Okay. So here, now, the sum of the first 77 terms of arithmetic progression is denoted by S77, and the sum of the first 10 terms of geometric progression is denoted by G10. So you have to find the difference. Again, you have to remember the formulas, right? So for the arithmetic progression, you have Sn, there are two equations, n over 2, a plus l. So first term and the last term for Sn, n over 2, then 2a plus n minus 1 times d. And for the geometric progression, we have Sn equals a times 1 minus r to the power n divided by 1 minus r. Or Sn equals a Rn minus 1 divided by r minus 1. So remember here, this first equation we use when the r values are in between minus 1 and plus 1. And this second equation we use when r values are greater than 1 or r values less than minus 1. So remember, so in this case, then we have to have first 77. So we don't know the last term. So we have to use this equation for the arithmetic. And for the geometric one, here we found the common ratio is 2, which is greater than 1. So you have to use this equation. Okay, so we know the equation and just we can find. So S 77. So you can use N is 77 over 2. And then 2 times A, the first value, plus then N is 77 minus 1. D is 2.5. So when you simplify this one, you will receive 7,000. So use the calculator. So now we have to find G10. So we have to use this equation. And here A is 5 plus D. D is 2.5. So 7.5. And then R is 2. So 2 to the power 10 minus 1 divided by 2 minus 1. So when you simplify this one, you will receive 7,672.5. Therefore, we can write F77 minus G10. 7,700 minus 7,672.5, which is 27.5. Okay, done. And now we came to the last question here. So the function f is defined by fx, okay, this equation, and x is a real value. Then express fx in terms of this, and where a, b, c are constants, and state the range of f. Okay. So fx equals, so you should remember here when they ask you to represent the equation like this, that means you have to use the completing square method, right? So when you apply for that one, the coefficient of x square should be 1. So I should take out minus 2. Then I can write x square minus 6 divided by 2. It's minus 3x minus 3 over 2. Now you can apply the completing square method. So minus 2 here, x minus half value of coefficient of x. So it's 3, so 3 over 2 square, and we have here 3 over 2 minus, you have to take the square of this minus 3 over 2. Minus 3 over 2 square. Okay, so when you simplify this, it's minus 2, and here we have x minus 3 over 2 square, and here we have minus 15 over 4. Okay, so now you can multiply by minus 2. Therefore, f x equals, when I multiply by minus 2, you will receive 15 over 2 minus 2 times x minus is 3 over 2 square. So we can write A equals 15 over 2, B equals 2, and C equals 3 over 2. We compare with this one. Then you have to say, okay, you have to state the range of f. Okay, so I can write here when the bracket here, when x equal 3 over 2, then f 3 over 2 equals 5 over 2, right? 15 over 2. And then when you put any other x value, positive value or negative value, doesn't matter, you will receive a positive answer for this bracket. And then times -2. So that means always their value is subtracted from 15 over 2. So that means for other x values, you will receive the answer for fx which is less than 15 over 2. So the maximum value you can have for fx is 15 over 2, right? Therefore, the range of fx is less than or equals to 15 over 2. That's it. It's kind of a logic. Right. Then here, the graph y equal fx is transformed to the graph of y equal hx by a reflection in one of the axes, followed by translation. It is given that the graph of h equal y equal hx has minimum point at the origin. Okay, so let's see something like this. So if I sketch this graph, so I will use different color. So here we have, as you can see here, the coefficient of x square is negative, right? So then it's a graph with the maximum point. And the maximum point you can have by taking x equals 3 over 2. So it is kind of a graph like this. So this is just a sketch to have an idea. So this is 3 over 2. And this is 15 over 2. And then they say that they take the reflection, okay, in one axis and followed by the blah blah blah, has the minimum point at the origin. So now when you take this reflection and transformation, the minimum point of this graph is here. So now the graph is something like this. So now what happened? So previously we had a graph with the maximum, and so now we have a minimum. So it is happened because we take the reflection around x-axis, right? So it is around the x-axis, and then what happened? So here, if I take the reflection, it should be like this in blue color, and then we translated that one by -3 over 2, right? Because we move that one to the left. So here it's 2 points. So you have to just state that one. So I will write like this: y equal fx has a maximum point. Fx has a maximum point. Okay, since y equal hx has a minimum point, the re reflection of y equals fx in the x-axis. X-axis. Okay, so we know the reflection, right? Then we have the minimum point at the origin, right? So in order to have the minimum point y equal hx at the origin, it is translated. It is translated to the left. By minus 3 over 2. So the translation is, so the translation is, so first we write the amount of x and the y value is the same. So 15 over 2. Because we translated also down. Okay. Then the next one. Right. Okay, so is it the final part? No, okay, we make another one. Yes. So here they're asking you to sketch the graph. Okay, see we have this equation and x values are less than. So that is the domain. Okay, so we have the domain. Explain why g is one function. You are not required to find coordinates. Okay, so what you have to do? We have to draw it first. So we have this one. So this is okay, here this is the same equation, right? So we have to draw. So this is, so now they are saying that x, we have to draw that one for x equals 0 or less than. That means it is this part, right? Because when we pass the y-axis to the right, then x values are positive. So we have to just draw that part. So I will draw like this. Sorry. Again, forgot to change. So, okay, something like this, and no need to indicate the values. So this is y equal gx. This is y-axis. This is x-axis. And then they are asking, okay, we have to explain. So here, 1 to 1. Why? Because when we check with for a particular y value, here we have only one x value. So for a particular x value, we have only y value, right? So we can say that for the graph, let's see here, the graph y equal gx for x less than or equal to 0 has one output for y value for each input value, let's say, which is x. So therefore this is one function under this condition. Okay. Now they're asking then, sketch the graph of y equal minus g on your diagram in part C and find the expression for minus, okay, g inverse x. And you should label two graphs in your diagram appropriately and show any relevant mirror line. Okay. So now you have to find the inverse. So you should remember. So inverse function exists if and only if the function is one function. So function g is one function. So yes, we have inverse. So how we can find the inverse? We have, okay, g was 3 plus 6x minus 2x square. So when you want to find the inverse, we interchange x and y. So by interchanging x and y, so I can write x equals 3 plus 6y minus 2y square. And then you have to solve this one for y. So I will bring everything to left side. Y square minus 6y and here plus x minus 3 equals 0, right? And so this is an equation for y, a quadratic equation. So I will use the formula. So minus b is 6 and then minus b square, 6 square minus 4, a is 2 and c is x minus 2. So divide by 2a. Okay, so you have to simplify a little bit. So here we have 6 plus or minus. Here you have 36 plus 24 minus 8x. Okay, divide by 4. So we can divide all by 4 here. So 6 divided by 4 is 3 over 2 plus or minus. And here inside also I'm going to divide. So here we have 60 minus 8x divided by, so 4, when 4 goes inside, then it becomes 16. Okay. So I can write 3 over 2 plus or minus here 15 over 4 minus half x. Okay, therefore I can write y equal g inverse x equals to 3 over 2 plus or minus 15 for 2x. Okay, so this is our answer. And then okay, we have to make the sketch. We have to make the sketch also for that. Then you have to know another thing. So here we know the domain, right? We know the domain of this one. So this is the domain. So we can write domain of gx is x less than or 0. And then the range. The range is, okay, we can find here. We can find the range when we substitute x equals 0. So the range is 3. That means this value is actually 3. Okay, so as you can see the graph, so the y values are, the maximum y value is 3 and then less than 3. So the range is x less than or equals to 3. Okay, when you take the inverse, we change this one. That means the domain of gx is the range of inverse gx, and the range of gx is the domain of inverse gx. So I will write like this. So the domain of y equal g minus x is the range of gx, which is x less than equal to 3. The range of and the range of y equal g minus x is the domain of gx, which is x less than or equal to 0. Sorry, the domain of gx is, we should write g inverse x values are less than or equal to 0. So now we can indicate here. The domain is x equal, I will use blue color. So this is 3. So it should be, the domain should be less than or equal to 3. Okay, so then we are moving to the right. And then the values. Okay, so the range is less than, okay, here's they're saying is less than or equal to 0. So then that means the graph should be below x-axis. Okay, and then we have to draw that one. So in that case, if you remember, we have to draw the xy line because that is the reflection around y equal x graph, right? So the inverse is, okay, this is y equal x. So the graph is the mirror image of your gx around this y equal x. So should start from here. So it should be the same, like same shape like this. So sorry, it's not the same, but okay. You should have the same shape of gx, and this is y equal g minus x. Okay, so it's the mirror image. Okay, so you in one place you can we may have the intersection and so on. Okay, so this is the answer for that. Okay, so with this one we completed the paper. So thank you very much, and so let me know your ideas, and if you have any suggestions, uh, so put a comment here. And okay, to do more this kind of videos, please subscribe and uh, give me a thumb. Okay, see you again.